the hardware resources and the 9 dongles at the same time. We needed to implement some simple facility to dynamically allocate and manage dongles, because often carrying the bag around they can unplug, or also to be able to reserve a dongle and let it be used by an external process in respect to our software. Okay. Okay, that the dongle management is one of the core characteristics that helped us to make the blue bag reliable, because as I said before, dongles and plugs, you think about bikers running into the blue bag, and that happened. That could be a problem, also because it will be quite difficult to stop, open the blue bag in an airport, replug the dongle, close the blue bag, and go on. So a reliable software is quite a requirement. Okay, to fire it up, you used just a quite cool electrical key lock switch, so that we just need to, okay, turn the key, and it turns on. It's quite cool. Getting the blue bag out of the car and turn it on with a key. Okay, we obviously needed some interfaces to remote control it, because again, if you are in an airport or in a train station or whatever, you cannot plug an Ethernet cable like we could do now. We reserved one of the dongle to establish communication, and we implemented a web interfaces that can be used, for example, from a PDA or a smartphone, because it's very small sized, and can be used to monitor the logs generated by the software, Linux logs, or whatever. Data are stored in a MySQL database. We thought about SQLite before, but there were a concurrency problem mainly. So we switched to MySQL, and in fact, the power consumption didn't increase too much, so that's good. Why we used an antenna plugged into a dongle? Because we needed to be able to get the data in very crowded places, and incrementing the range of one dongle let us possible to see a device before they actually get in the range of the other dongles. So we can scan for devices, and then the software is already prepared to retrieve information when the devices come into the range. And of course, the multi-threaded design is needed to be able to gather information from multiple phones at the same time. Okay, now let's go for demo. Okay. Yeah, these are the Bluetooth addresses of the dongles inside the blue bag. We connect to the blue bag using SSH over PAN-D, using the PAN daemon. Okay, we wrote a little lame script to automatically connect, because if a dongle unplugs, then we wouldn't be able to know what Bluetooth address has to be used to reconnect, because the order changed. Okay, let's go to SSH. Okay, now we're in. Okay, as you see, it's just a Linux system with a VIA processor. Okay, these are the 9 Bluetooth dongles. The first one, as you can see from the Bluetooth address, is different from the others and is the Linksys one. Okay. Now we switch to the web interface. As you see, it's kind of small because it's designed to be used from a PDA, for example. Oh. Okay. That's good. using the interface, you can actually edit some of the configuration parameters. Here, the form right now, at the moment, can be used to change only some of the parameters and are actually the parameters useful that needs to be changed maybe during a survey. You can change the task performed by the blue bag because the software can be used to perform just a survey that is retrieve information about devices, type, models, and service list, and so on, but can be used also to perform brute force attack using the red fan tools, or can be performed can be used to perform what we call the stupid test, which is try to see how many people would actually accept a transfer from unknown people. Yeah, the results are kind of surprising, but we'll see later about that. Okay, we can review the configuration so that we can be sure we're actually doing what we think that we'll do. We can, okay, down there, quarantine devices. Okay. Okay, we can tell the blue bag to, for example, during that stupid test, which is kind of intrusive, we can tell the blue bag only to contact a specific list of targets so that we can make tests in lab without anyone.
Oh, my shit.
No. Okay. Oh, let's go on. Okay, log tail. No, that one. Okay. The start button do what you think it does, obviously. Okay, so start. Yeah. Okay, now if you look at the log tail just tells the content of display the tail of the content of a series of files that can be specified in configuration. In that case, we tail the content of the blue bag log, which is the log generated by our application, and the content of our log messages, which is quite useful to look for other problems, for example. Okay. Okay, the last 5 devices voice, which is not kind of working. Okay, it's working. The last 5 devices will actually extract data from the database and show a brief summary of the characteristics of the last devices found by the blue bag. And in the session info, the application summarized some interesting information, such as how many time remain to this session, how many devices it has found, the number of dongles available in the blue bag. That is quite useful to know if a dongle is accidentally unplugged. And the number, sorry, back? Okay. Some expected demo effect. Yeah. Okay, now we just disconnected. Yeah. Okay. It will show us the list of devices in the queue to be processed, and also what we call the hostile devices, which are devices from which the software hasn't been able to gather every kind of info that we try to get. Okay. Yeah. Okay, so well, if you maybe also later we can play a little bit more. We can show you something else. Okay, let's move on. During our first test, we focused on identifying devices. We wanted just to know how many devices are actually visible, how many have Bluetooth active, and surveying different contexts, different areas. where we expected to find different kind of users. So we wandered around with the blue bag in shopping malls, in a train station, in the major Milanese airport, and we gather info not only about the number of devices, but info that can help identifying the type and the model of, the devices, so the SDP service list and so on. In a total amount of less than 24 hours, we identified more than 1,400 devices in these different contexts. Let's see some number. Okay, the 93% of the devices found were mobile phones, only 3% of computers, 2% PDAs, GPS antennas, and others, but minor percentage. What's interesting is that the 60% of the mobile phones were Nokia ones, while only the 1.8% were Motorola. That, in fact, could be explained by the fact that Motorola phones, by default, are visible in invisible mode or discoverable mode, sorry, only for a small amount of time, after which they switch to non-discoverable mode. The 80%?
Yeah, the 80% of these devices
of the
Nokia devices.
The 6310i Nokia devices
Have denial of service or denial of service vulnerability, and also the ERFCOM port, the channel 17 and 18 are open and without requiring pairing.
Mm-hmm. Okay. Some other numbers we try to extract from the database was what we call the visibility time. That is the time that a device has been, or the average time a device has been actually in the range of the blue bag. That's kind of important because that represents the time that an attacker has available to perform information gathering and attacks. And for example, in the airport, the time was more than 23 seconds. That's kind of long time interval. Okay, after we published the report, we've been kind of quickly slashed out. We had many interesting comments, some rude ones, but we tried to answer to some questions and to clear some points. One of the questions was, isn't that the same old stuff? Well, that's not true because we gather more data than others did before. We have long sessions, and we developed a kind of framework to do that kind of thing, and so on. Another guy said that there's no security risk posed by Bluetooth technology and so on, and in fact, a Slashdot reader answered with a quite funny answer.
You remember Back to the Future? Back in the Future, yeah.
That's a good answer. Another reader said that the serving scenario is not much interesting. It's quite pointless because what's